Okay, a quick video on normal distributions and statistical tables. How to use statistical tables like these tables, these ones, to figure out, probability of certain things. Anyway, let's get started. So this table, generally speaking, what happens is this table is telling us the area under a curve. It's telling us how much is shaded. Okay, how much is shaded. It's kind of like, it's very similar to the 68, 95, 99.7 rule. So the 68, 95, 99.7 rule, the empirical rule, it tells us, for example, that between a z-score of 1 and -1, in other words, one standard deviation above the mean and one standard deviation below the mean. So that area underneath the curve that I've shaded in and it's just disappeared randomly, that area is 68%. In other words, for any distribution, for example, let's say we do a test and the mean is, let's say, 14 and standard deviation is 2. The mean is 14. Okay, let's just say the mean equals to 14 and the standard deviation equals to 2. Okay, then we can say that how many percent of people got between 2 below 14, which is 12. So let's just say 12 there. And, well, the mean is 14. Let's just write 14 here. 12 and 16. Around 68% of people will have gotten a score between 12 and 16. Z-score of 1 to -1. Anyway, that's that. So with the 68, 95, 99.7, this is how the shading occurs. And that we know is going to be 68%. This table is telling us that this table is talking about that area from 0 to Z. From 0 to Z. Now, what is Z? What does Z mean? Well, the table says if Z is 0.1, right? Then from 0 to 0.1, like instead of Z, Z is 0.1. So I'm going to write 0.1 there. From 0 to 0.1, what's the shading? 0.0398. Now that's given as a decimal, so it's not as intuitive as the 68%. But we can convert this into percentages. That's just 3.98%. Hopefully that makes more sense. So what it's saying is, from 0 to a z-score of 0.1, right? That shading, that how many percent of people will have gotten a score between 0 and a z-score of 0.1? 3.98%. Okay? It's very similar to 68, except it's talking about that specific range. Okay, so there are other sorts of tables as well. For example, let's look at this table. See, this table is linked to that diagram that has been given. And so this particular table, that's a different table. This is a different table. This is a different table. And in this table is linked with that curve, with that diagram. And in this diagram, the shading is from Z to -Z. It's different. Over here, it was from 0 to Z. Okay? And that's why the numbers are different. Over here, it's from Z to -Z. Well, what's Z? Well, the table is saying if Z is, let's say, 0.5, if Z is 0.5, then the area that is shaded is going to be 38.29%. So, for example, if we were to draw a normal distribution, we do a normal distribution, and we're saying from Z to -Z. In other words, if Z is 0.5, so from -0.5, from -0.5 to 0.5, to 0.5. What will be that area? I'm not sure why it keeps disappearing. What will be that area? And that area, the curve says, is going to be 38.29%. 38.29%. It's given as a decimal. It's still a percentage. Okay, we can convert this into a percentage. That's 38.29%. This area is 38.29%. For the sake of, if you're curious, we can mash this up with the empirical rule. Remember, the empirical rule says 1 to -1. Well, maybe this table has that. This table has 1 to -1. And we can see it's 68.27%. See that 68% we learned, the empirical rule? That's an approximation. It's not perfectly 68%. It's actually, 68.27%, and even that's probably rounded off as well. So same with the 95%. It's not absolute 95. Over here we can see it's 95.45%. But we use 68, 95, 99.7. It's a rough number, and we use it as approximation. It's good enough for most purposes. Anyway, so this table is telling us the area between two z-scores. Well, the same z-score. So that's like 1.5. Negative 1.5 to 1.5. What's the area between it? 86.64%. And then we also have, like this. We have something like this as well. So this is a third type of table and a diagram. So the first type is this one, from 0 to z. Second type is from negative z to z. And the third type that generally you'll see is the one that's to the left of z. So from z all the way till negative infinity, so to speak. So all the way, keeps going, right? It doesn't end, it just keeps going. To the left of z. Okay, just note that this whole thing is going to be 50%. What you see right now is 50% because of the symmetry of the normal distribution. That whole thing is 50%. But anyway, to the left of z. So for example, if the z-score is, let's say, and by the way, how do you read this table? The way we read this table is, it's going to be 0, and then we add the 0.3. What is 0 plus 0.3? It's 0.3, right? So 0.3, a z-score of 0.3, we'll have that. What is 1 plus 0.5? 0.5. In other words, 0.5. 1.5. It's a z-score of 1.5. Z-score of 1.5. So if that z is 1.5, then what area are we talking about? What's that shaded portion? That shaded portion will be 93.3%. 93.3%. Hopefully that makes sense. That's how the table works. And we just answer questions. Very, very similar to the empirical rule. You'll still need to do the old where did I put the different sorts of, was it here? No, hang on a second. That scores. I can't remember. That document here, should be here. Yeah, this stuff. You still need to know this, but instead of the 68, 95, 99.7, now you'll be using the table to figure out all these sorts of questions. But you just use the table. So depending on what you get. It's just like a puzzle type of thing. So you gotta solve the puzzle. Now I hope that helps. Let me know if you have more questions, if you understood, didn't understand. Just let me know on Slack. Unless you ask questions, I don't know what you're not understanding. It's not enough to simply tell me I don't understand. I don't know what you don't understand. So I'm more than happy to help. I'm more than happy to make videos. But be more specific, and I can help you with whatever you're not understanding. When you say I don't understand anything, it's not very helpful, because I don't know what particular point you're stuck on, and it's very hard to help. So ask more specific questions to get specific help.